This video will provide a basic understanding for how a digital light processing stereolithographic 3D resin printer works. This type of printer utilizes a resin tank or vat to hold resin while a build platform lowers down to extract the part out of the resin tank. The build platform is attached to a ball screw that raises and lowers the build platform in and out of the tank, while a peel mechanism separates each layer from the bottom of the vat. For most printers of this type, the vat is a consumable due to the special non-stick coating on the bottom of the vat that allows the part to be peeled off after each curing step. The vat only needs a small amount of resin for even large parts. The vat is peeled using a servo motor that rotates and pulls the vat down, gently peeling the part off of the bottom of the tank. Beneath the resin tank on the bottom half of the printer is a high-definition DLP projector, along with all the necessary circuit boards to run the printer. The projector projects the image up to the bottom of the vat to cure each layer of resin. This printer uses the Acer DLP projector. Not every stereolithographic printer uses a projector, but rather some use a laser to draw each individual layer. Here you can see the image being projected on the bottom of the vat right before the peel process. This will happen many hundreds or even thousands of times. The exposure time for each layer is controlled with the software used to set up the print. This printer uses the open source software Creation Workshop to slice each print. This printer is controlled by two different circuit boards, a microcontroller that sends commands to the servo motor, stepper motor, and on-off commands to the projector, and a Raspberry Pi that sends images to the projector and G-code commands to the microcontroller. The bottom of the vat you can see here with the image projected onto it slowly cures each layer of resin. After the curing process, the peel process peels the part off the bottom of the vat, and the build platform moves up by one layer thickness. These layers can range from 10 microns up to 100 microns, depending on the resolution desired on the Z-axis. You can see here the red, blue, green stripes flowing across the vat from the color wheel on the projector. Some have modified their projectors to remove this color wheel. I have not. Photopolymer resin is used on these types of printers. This is resin that is sensitive to light, in particular ultraviolet light. This resin cures into hard plastic when exposed to ultraviolet light and is a powerful solvent. Because of this resin is not the same as the ABS plastic used in typical fused deposition modeling printers, and is not suitable for parts that will come in contact with food, or for children's toys, or anything that would spend prolonged contact with the skin, as it may cause irritation. This part took about 560 layers to print, about 3 hours, and is a battery holder for a friend's quadcopter. Be sure to comment, like, and subscribe.